The uniform plane lamina shown in figure 3 is formed from two squares ABCO and ODEF and a sector ODC of a circle with centre O. Both squares have sides of length 3A and AO is perpendicular to OF. The radius of the sector is 3A. So what we're being told there is that this is a quarter circle. Show that the distance of the centre of mass of the sector ODC from OC is 4A over pi. Note it says in part A, you may use, without proof, any of the centre of mass formulae given in the formula booklet. And we're going to need to do just that. So from the formula booklet, we're going to use this. Sector of circle, radius r, angle at centre 2 alpha, 2r sine alpha over 3 alpha from centre. Now, as discussed, this was 90 degrees or pi by 2 radians. And that means that 2 alpha is pi by 2. So alpha is pi by 4. Now, it's going to be symmetrically along here. So that if that is our centre of mass, it's at a distance d, and d is equal to 2r sine alpha over 3 alpha. Now let's substitute in what we know. We know that the radius is 3a. And then we have sine pi by 4. And we'll divide that by 3 times pi by 4. 3 pi by 4. So doing a bit of algebra with that is going to give us 8a root 2 on 2 divided by pi. So the 3's cancelled there, that's why there's no 3 left. And the 4 flipped up to the top, multiplied the 2. And then simplifying that would give us 4a root 2 over pi. Now we're after the distance from OC, which means we're just after the x coordinate here. So x is just going to be, remember this angle here is pi by 4, it's going to be 4a root 2 on pi, which is the hypotenuse of this right-angled triangle here. And since this is the adjacent, we're going to use the cosine of pi by 4. And so we have 4a root 2 on pi times cos pi by 4 can be written as 1 over root 2, and then the root 2's will just cancel, and I don't know where I wrote 4 there, that's a pi on the bottom there, and then that is 4a over pi. Now part B asks us to find the distance of the centre of mass of the lamina from FC. So that's taking this like the y-axis. I'm going to collect the information in a table as I did in question 3. So we'll have area and we'll have position. So that's the centre of mass of each of the 3 shapes. Now this would be the centre of mass for this one here. So the area there is going to be 9a squared. And if we think about the coordinates here, taking AD as the x-axis, that is going to be at negative 3a over 2, negative 3a over 2. Then we have the quarter circle lamina here, and we know the area of that would be 9a squared pi over 4. That's just pi r squared divided by 4 because it's a quarter circle. And as we just worked out, 4a over pi would be the x-coordinate. By symmetry and the fact that it's below here, we know that this would be negative 4a over pi for y. And then the remaining square here would have an area of 9a squared and coordinates 3a over 2, 3a over 2. So, if we're after the distance from FC, we're after x bar. So, the total area is 18a squared plus 9a squared pi on 4. And if we multiply that by x bar, that is the moment of the sum. And then we want the individual moments. So we have 9a squared times negative 3a on 2. Then we have 9a squared pi on 4 multiplied by 4a on pi. And then we have 9a squared times 3a on 2. Now it's reasonably clear here that this and this are just going to cancel. So if we do that, we have the 18a squared plus 9a squared pi on 4 x bar is equal to 9a squared pi on 4 multiplied by 4a on pi. And there's some cancelling here. Pi's will go, 4's will go. And so let's write this over a common denominator. We get 72 plus 9 pi all over 4 a squared x bar is equal to 9a cubed. And then dividing everything by 9, we get 8 plus pi over 4. We could cancel the a squared with one of those, and then we've got just x bar here. And if we divide it by 9 on the other side, we'll just have a. And so 8 plus pi x bar would be equal to 4a, giving us that x bar is equal to 4a over 8 plus pi. The lamina is freely suspended from F and hangs in equilibrium with FC at an angle theta to the downward vertical. Find the value of theta. So if we draw the vertical on here like so, we're saying this angle is theta. And that means the angle here would also be theta. Let's just draw that triangle out. So it will be something like this. And this angle here is theta. This is a right angle. And by symmetry, since we found that x bar was 4a over 8 plus pi, y bar, remember that would be from AD, so it will be down here somewhere, that would be negative 4a over 8 plus pi. And since we know that this has to go through, so if this is F, this needs to go through the center of mass. I can't call that C because C is already on the diagram. Let's call it G. Since that has to go through G, this distance here would be 4a over 8 plus pi, and this one would be 3a plus the 4a over 8 plus pi. And so tan theta would be 4 over 8 plus pi. Let's just put the a there for the moment. Over 3 plus 4 over 8 plus pi a. And of course the a's will cancel there. And so theta is just going to be the inverse tangent of this stuff in here, which we can all put into the calculator, and it gives us 6.1 degrees.